All right. So today we'll be discussing the inclusion and exclusion criteria screening. I'll be giving you a demo on how to use Ryan, a software, an online tool which can help you through your screening. And then there's data extraction. We'll be talking in brief about quality assessment as well. So if you would see the beginning of this presentation, we will be actually going a bit into the inclusion and exclusion criteria I had briefed you all during our proposal writing session. So let's just start with that. So inclusion and exclusion criteria again is based on your PICO, whatever topic you choose. On the basis of that, you choose a set of criteria of the studies you think is exactly matching your topic and which you want to be which you'd want to go into further investigation. And exclusion will be something which is completely out of the scope of the topic, or something which is completely opposite, or a population you do not want to be under consideration in. So a difference here from the ones that we did in the protocol writing is that there will be a statement here regarding the study types that we are including, especially like we are discussing right now in the context completely of reviews, systematic reviews, and meta-analysis. So when you choose when you choose studies you want to include in such kind of review, it is always preferential that you include studies which are primary studies. So you'll include all observational studies, you'll include trials, case series, and if evidence is really emerging between an association. For example, there was the COVID pandemic and people did not know what exactly that disease is associated with, and there were a lot of scattered case reports here and there which were and then from these case reports they found few associations which were not really highlighted earlier. So in such kind of associations where the evidence is very newly emerging, case reports would also be one of the study designs you're looking to include in your review. Then another thing is that usually in systematic reviews and meta-analysis, we exclude any other reviews because we're going for direct analysis of like primary data, what they have observed in their cohort of population, and we'll use that data for qualitative and quantitative synthesis. Now, gray literature, as I mentioned earlier, this is any form of literature which is not published. For example, newspaper articles, any reports from any website for that matter, that comes under gray literature, which basically have not undergone peer review. And then language restrictions, if any. So if you're trying to analyze something in a study, there may be some language restrictions that you may want to choose because you fear that you would not be able to interpret, like get the actual essence of what a paper is talking about if it's in a different language. So Boris, can you launch the first poll?
It's up.
Yeah, thank you. So this is again a question that refers to our proposal writing session, in which one of recommendations which is recommended by editors and reviewers is that you not include terms which are exactly the opposite of each other in your inclusion and your exclusion criteria. For example, in this instance, writing inclusion as including all women in the reproductive age group, it is already implicit that you are going to exclude children of non-reproductive age group. So it doesn't have any point of including that in writing that in the exclusion criteria. Similarly, if you're considering an adult population greater than 18 years and you've written that in your inclusion criteria, you need not mention that children will be excluded. It is already implicit. However, when you write, you're including adults greater than 18 years in your inclusion criteria. And then in your exclusion, you're stating that I'm going to exclude all those adults who have diabetes. Then you're choosing a subset of the original of your inclusion population, which you're trying to exclude for some reason. So it is always advisable and recommended that you not use direct opposites, or a fact and its entire negative fact as inclusion and exclusion criteria. So most of you have gone with no, so I'm happy you guys recall that. Yeah, so now we go into how you form your criteria. So some people, they prefer to select a time frame for their search results. So maybe literature that has been published only in the past 10 years, especially if the evidence on this is very extensive, and you want to look into only that form of evidence which has come recently within the past decade, and you want to analyze it, you want to show that there is some form of trend which is emerging right now. Then geography and language. Perhaps you want to study in a specific population, maybe in only Indian, in only Indian people, any kind of association. So you want to, if you want to do it, then you can choose a geographic restriction as well. Language, as I described earlier, some people, they prefer to select only English articles, or whichever articles they understand and feel comfortable with. Research constraints, again, is the same as study design. So you would include all observational studies, for example, trials and case series. So another point here is when you're choosing which kind of study designs to include, studies like systematic reviews and meta-analysis, which analyze only RCTs, they are like the top tier of evidence. When you're including observational and RCTs, the most likely reason that you're doing that is because you do not have enough trials to synthesize your result. So, when any medicine becomes a fact, like it is a general, it's published as a guideline. It is published by big conferences as a guideline or a consensus. It is often a derivative of meta-analysis, which are basically meta-analysis of RCTs. So doing a review of trials, that is like at the highest level of evidence. And following that, you would take up observational and trials into as an inclusion. So as you're going down that pyramid, you're kind of reducing your level of evidence. But that again depends on what kind of literature you have. If you have only 2 RCTs, it's very difficult to include only 2 RCTs in your analysis and try to frame any suitable result from it. So again, it depends on the literature. Then you would try to form a structure for writing your review. So if you remember, last time we discussed on lung cancer and HRT. So for those who are not there, we'd chosen a topic that is the incidence of lung cancer among women among non-smoking women taking HRT. So this is a possible inclusion and exclusion criteria which you could do for a review. So again, your inclusion, ideally, to make it easier for you, you can frame it in a PICO format. So study population, you would choose women attaining menopause and with no genetic predisposition to cancer or no past history of carcinoma, because that would again it'll introduce bias to your results. Women who already have some risk of metastasis or any family history of lung cancer, it may be that HRT may not have caused the said incidence of lung cancer. And women, obviously, with no history of smoking, because that itself is a strongest risk factor for lung cancer. Then here the intervention would be prescription of any form of hormone replacement therapy since 1 year. So We've taken 1 year as a cutoff value here. And this again, if you would think why you would choose a specific timeline, this again depends on the time you would think the cause leads to effect, or the literature says that within this much amount of time you would see some form of change in your population under consideration. Then control would be obviously women who haven't taken HRT, because I want to compare women who have taken HRT, women who are not taking HRT, and between both of them, what is the incidence of lung cancer. Then the outcome here would be again incidence of any lung cancer, and it would be only new onset lung cancer and first detected after usage of HRT began. Now, again, if you're taking HRT and within 2 months there's a lung cancer detection, it doesn't really make sense that you're on a cause and effect basis that that the HRT prescription led to lung cancer. So again, that is the justification for 1 year there. And here it's only new onset. We do not want any lung cancer metastasis cases here. And study designs. So study designs here would be again, since you would consider that I have done my literature search already, and I see that there are obviously there are no trials on this topic. So it would only have observational data. So I would include all cohort studies, all kind of observational studies which have been done on this. Maybe I would not go for including case reports, because we already have a lot of observational studies, or a lot of cohort studies being done on this, and adding case reports would unnecessarily make my level of evidence weaker. And articles in English language, if I'm not comfortable translating it into a different language, or maybe I think that I will not be able to interpret it as the author intended because of language barriers. Then exclusion criteria here would be women with with any genetic predisposition or any risk of cancer, or any past history of malignancy, which may be a precursor to the incidence of lung cancer. Then women obviously with a history of smoking, or use of HRT which is less than a year, or lung malignancies which are metastatic, obviously. And the study design. So in the study design, I would seek to exclude I would seek to exclude all kinds of review articles, because they are already reviews which are done on the level of on the studies which were published then. Now I want to again compile all the newer studies which have been published and see whether I'm getting the same facts or not. Then abstracts, obviously, because they will not have the complete data on the baseline characteristics, or the complete outcome sheet. They would if you've seen conference abstracts, they would publish only their positive results, and they will not highlight results on the baseline parameters, or any results which is not agreeing with the hypothesis. So that there leads to a bias. Then editorials, commentaries, and letters. These are very small, hardly 500 to 600 word papers, which do not really give you a big picture of the study done. So these are automatically excluded. It's like in almost all systematic reviews and meta-analysis, the last line, that is review articles, abstract, conference articles, editorials, commentaries, and letters. This is like a given exclusion criteria common across a lot of systematic reviews and meta-analysis. And then perhaps you could include their observational as well. If your meta-analysis is only of trials, so you would only take up trials in your inclusion criteria, and your observational studies will come under exclusion. So this is an example for a topic on HRT and lung cancer. Does anyone have any doubts till now? Please feel free to unmute yourselves or put it in the chat box.
There's one question in the Q&A section. If you want, I could read it out for you.
Okay,
it
the
states
open
that
epi, right?
in the last class, you mentioned OpenEpi website. Kindly share its utility once again in the end. So
Yes, I
just
will
wanted to
do
let
that.
you know about that.
Yeah, thank you so much, Boris. I'll get back to that once we at the end of this session. Okay, then so after setting your inclusion and exclusion criteria, you would proceed towards screening. Screening is essentially of two components: title abstract screening and full text screening. And this is completely to make your workload easier. You do not want to look into articles completely from page 1 to page 20 if it fits to your inclusion and exclusion criteria right away once you've downloaded your results. You want to first screen through the title and abstract. In abstract, see if their outcomes are somehow relating, fitting into your criteria. You would pick a lot of it from the thousand. For example, if you have 1,000 articles, you would pick around 50 or 60 articles. Like, you would be surprised how many articles get excluded at this stages. In the stage of title abstract, because you would immediately identify studies which are reviews, because in their abstract it would be written, in this review we are trying to do something, so that will be excluded. And then you can find any abstracts that is published in this conference, so you know that this is an abstract, I don't want it, I'll be excluding it. So title and abstract, it gets you helps you focus on your required on a small set of articles. And from that small set of articles, you will look into full text screening, in which you will go through each and every point. You'll see if the outcomes you want to consider in your review, if they have reported those outcomes or not, and perhaps in the proper measure that you need or not. And then you would seek to include or exclude that study. So screening is in any form of review is primarily done through Prisma. So Prisma is preferred reporting items for systematic reviews and meta-analysis. This tool, it helps you streamline whatever methods you're doing while conducting the systematic review into a brief summary flowchart. And it gives you pointers on how you would proceed and what is the correct step of doing a review. So Prisma, it includes a procedural checklist and a flow diagram to illustrate the screening process. So before I go into the details of Prisma, Boris, can you launch the second poll, please? So I'm sure many of you would have already heard of Prisma, and there is a very common belief, a misconception or a belief that of our Prisma, is Prisma flow diagram and checklist the same or not? So please put your votes in. We'll discuss after this. Yeah, so I'm really happy you guys know that they both are different. Prisma flow diagrams and checklists are entirely different. Your flow diagram, it helps you to I'll be showing let me just show the flow diagram. So this is the flow diagram. It will help you summarize what all databases you chose, the number of articles you got from that databases, and basically how many articles at the end you've gotten to include in your review. So just discussing this point by point. So here you would, so first there is records identified from databases and registers. Registers usually people tend to not to use, so you would include databases as well. For example, you would include PubMed, Cochrane, Web of Science, Embase. So you would, and after, for example, last time we'd gotten 32 results when we'd run the search in PubMed. So I will put PubMed is equal to 32. And then Cochrane, suppose I get 100 articles, then I'll put Cochrane equal to 100. And then there is this records removed before screening. So if you import all of these into any standard software like EndNote, Ryan, or Covidence. These are three tools which help you to automatically identify duplicate records. So what does duplicate records mean? It means the same study is there in more than one database. So I've collected my data from PubMed, I've collected my data from Cochrane, and there is a study which is there in both of them. So I first need to filter out those the duplicate records before I continue my screening. And then is record screen. So for example, you had a total of 1,000 records you identified, 200 went off in duplicates, and then you have 800 records you're screening. So the first records excluded which comes there is usually the number you would put after you've completed your title abstract screening. So once you complete your title abstract screening, out of 800 articles, say you excluded 700, and then you have remaining 100. Then that would come under reports sought for retrieval, which is 100. And reports not retrieved would be studies that you simply cannot find through searching any form of any databases. Like you have the link, you search it up, but you do not get the study. Perhaps due to it's not published yet, or the text isn't available in the literature yet. So that would come under not retrieved. So out of say 100 articles, I could not retrieve 10, and then reports assessed for eligibility 90. And then when you have the reports excluded and the reason, in this is basically a summary of your full text screening. Like here, out of the 90 articles, maybe 20 of them were abstracts. Then I can put reason 1 is abstract and then put the n is equal to 20. So like that, you would continue. And at the end, you would include the number of articles which are you would write the number of articles included. So for example, I include 10 studies, and number of reports included in the study is equal to 10. So that's flowchart. The software for duplicate studies detection. Okay, so there is EndNote, which is automatic. Then there is Mendeley, and we have Ryan and Covidence. So Covidence, it is paid, and I don't think colleges in India subscribe to Covidence, but it's like the best because it automatically removes the duplicates, and it's quite accurate. So is EndNote and Mendeley. That also removes the duplicates automatically, and the remaining duplicates, it gives you an option of selecting whether one is, if it's a duplicate or not. And then the last one is Ryan. So Ryan has the issue of you having to actually manually select if the duplicate is a duplicate or not. It just detects the duplicates for you, but you will be the one who's reviewing, like, both the studies side by side and choosing whether it's a duplicate or not. I'll be showing it in the demo. So yeah, the softwares are basically EndNote, Mendeley, Ryan, and Covidence. Okay, so Prisma checklist. Prisma checklist is a different thing altogether. So it is not necessary to include in your study, but many of the journals, they ask for a Prisma checklist at the end of your paper, in which you would basically detail a specific heading, and if you like which page number have you mentioned that in your manuscript. So suppose the first page is your abstract, and the second page would be your introduction, for example. Then here it mentions the title, identify the report as a systematic review. So when you're doing a systematic review and meta-analysis, it is a requirement, a need from all journals, and it's like the convention that you have to write a systematic review, or a systematic review and a meta-analysis after the title. So you'd put a colon, whatever your title is, you're comparing an efficacy, and then you'd put a colon and you'd write a systematic review or a systematic review and meta-analysis. So that's a must. So if that's mentioned in page 1, then you would just put 1 here, like it's included in first page. And then your abstract, where you've mentioned your abstract, suppose it's there in the first page itself, then you'd put number 1 there. So similarly, for each and every section, you have different requirements that needs to be met according to Prisma. And we'll be going more into what exactly should each method, each section include while writing a manuscript in the next session, which is manuscript writing. So tools for screening. For screening, it's the big 3: EndNote, Covidence, and Ryan. So EndNote, again, as I mentioned before, it helps you to detect duplicates. It is automatic as well. There's an like just when I use it, there's an option in EndNote which helps you to refresh the articles. That is, update the articles according to the latest publication date. So if you do that, your detection of duplicates becomes more accurate, because the problem with EndNote is that it does detect your duplicates, but there are a lot of articles which are not detected, and you would find later that yeah, there were many duplicates remaining. Covidence is quite accurate in that manner. It it's it also helps in automatic duplicate detection. And then there's Ryan. Ryan, it helps to detect. For automatic detection, there is a fee, I think $5 a month, but for automatic clearing of the duplicates. But manually, you could do, and I'll show it to you how. So, some people, what they do is that they import everything into EndNote, and from EndNote they detect the duplicates and then export the whole bulk into Ryan. You could do that, but make sure that when you're exporting from Ryan, you do it in when you're exporting from EndNote, you do it in .riz. Other formats work, but .riz is the one which gives you all form of available data. Like it exports the title, the abstract, all the keywords as well. So it's like the best form of exporting, if you have an option of exporting in different formats. Okay, so title and abstract screening. So this again is something. If you're making a protocol before you're beginning your review, then you would have outlined, or you would have already outlined these criterias. And here again, as I mentioned before, it's removing the bulk of your a bulk from your screening results, so that you can narrow down on a specific set of articles which matches your criteria. So one thing people do is in screening is that they set off doing a decision of one person per article. Like only a single person does screening, or if it's 1,000 articles, they divide it among 5 people, for example, and 200, and one person doing 200 articles. While you can do that, like it's not wrong, but it is not advisable as well. So if you would search PubMed itself, you can find a lot of studies which have actually assessed the quality of published systematic reviews and meta-analysis, comparing single author screening versus double author screening versus triple author screening, for example. Like one article is scrutinized by how many number of people, and they have it's a published data that articles which have a single author screening are not accurate, because there is a lot of chance of errors. So it is a requirement, like it's not a requirement per se, but it is generally it is recommended, advisable that you get your screening done, your title abstract screening done, in such a manner that each article would be reviewed by at least 2 number of people. And then at the end, once you have all your decisions done by the 2 authors, another independent person can help you, independent person of your group can help you review the conflicts. For example, one person would have said this is excluded, and another person would have said it is included. Then a third person can look into it and decide based on their criteria whether to include it or exclude it. And all this information needs to be detailed in your methods. Say you're a team of you're a single person doing a review, and it's only you that has done the screening. Then that also has to be mentioned, even if it's not recommended. You will have to mention that screening was done by two reviewers, and then in the brackets you can put their initials. So then after you get your set of articles ready from title abstract, so what you've done till now is, let's just say that it's a team of 4 people. You've assigned 2 people to do title abstract screening. They've completed. They had their disagreements, for example. Like one person said included, another person said excluded. And the third person a third person of the team, they gave their opinion on whether it's like the final opinion on whether it's include or exclude, and you've gotten your results, your articles ready. So after that, you'll have to look into full text screening. So full text screening is really important because there are a lot of studies which are not retrievable in the sense that they are ongoing studies. So especially if you're using Cochrane and clinicaltrials.gov as your databases for downloading articles and screening them, you will find a lot of studies which are ongoing, and they neither have their results posted, nor is it an actual published paper. So in ideally, these studies are excluded, especially if they have no results. Because if they have no results, how will you like how will you analyze that study? So in full text screening, um, there are a lot of ongoing studies which get included after your title abstract. And here in the full text, this is the stage where you would exclude them ideally. And apart from that, if you if you already have the paper, like you what you do is based on the URL, you would download the article and you would check each and every thing from your PICO and your study design criteria from your inclusion and exclusion criteria. So if it matches your population correctly, what were their inclusion and exclusion criteria? Is your topic under consideration, the population under consideration, being excluded in that study? If yes, then that's an automatic exclusion for that for this original study. So again, PICO, so population intervention control and outcome. You would check each point of these in the respective study to see if it's correctly if it matches your criteria or not. Yes. So after this, let's just go into Ryan. Does anyone have any doubts till now? All right, we can proceed to Ryan. So Ryan is an open access um, online software which is specifically designed to help you through your through any review for that matter, not only systematic review and meta-analysis. It helps you in narrative reviews, scoping reviews, any form of reviews where you need where you would require screening as your criteria. So Ryan, basically, it helps you invite other people in your group as well, so that multiple people can work. And the point that I mentioned earlier is that each study needs to be scrutinized by at least two people. That is really facilitated by Ryan. Covidence does the same as well, and Covidence is like as a personal preference works much better than Ryan. But then again, it is not free, and I don't think any of the colleges here subscribe to it. Then there's accessibility. It's Ryan is available as a software, as a mobile software, and as an online tool. My suggestion would be to always use it in the web-based tool, because the mobile app, it has certain limitations. It's difficult to import articles there, and you have a limit of, I think, 100 articles per day that you can screen. So that's not needed. It's better you would use Ryan in your laptop in the web-based form. So without further ado, let me start the demonstration on Ryan. So if any of you have, I did mention that you join with your laptops. If any of you has, then they could log into Ryan and try and see the steps that I'm doing. So yeah, so once you log into Ryan, this would be your interface. What you would do here, once you log in, is create a new review. So again, this will be the lung cancer and HRT study that we've been discussing since the last session. So I'd give a title here. So this title can be anything. It can be the actual title of your study or just anything to help you basically identify what this review is on. And then the review type. Say I'm doing this as you can select any of these, and say I'm doing it as a meta-analysis. So I'll be selecting this. Review domain is biomedical. Then your files here. Here you will add your files. So I have already kept the articles downloaded. So this was my PubMed search, and this is my embase.ris file. So I'll be importing both of them. And here you can add any of your members, just put in their email and add them as a collaborator or a reviewer, and you can proceed. Okay, so if you go to review data here, you can find the number of articles you would obtain from each database. So it says from PubMed, I have 167 results, and from Embase, I have 966 results. So after this, you would detect duplicates. Now, as I said earlier, Ryan helps you detect your duplicates automatically, but it does not automatically resolve your duplicates. For that, you'll have to do it manually, or there's an option of purchasing as well. So I have 309 duplicates here. So what would you exactly study, like assess when you're manually doing duplicates? Like the best in the one that will take the shortest amount of time is comparing the DOI. So I see the DOI is same here. Then I'd automatically know that it's the same article, and I would choose any one. This again, the same DOI between both of them, and I'd choose. Now, just keep in mind that even if the article here, you do not need to do your screening here. Here, you're just resolving the duplicates. So you don't have to think whether this study comes under your inclusion or exclusion criteria. So this again, same DOI, or you could also use the similarity percentage here and select. This, for example, here, this is a different study since its DOI is different. But what the title is telling me is that this is perhaps the abstract of this study. And the dates also match. So this was published a year back, and this is published in 2024. So ideally, what you would do is you would select keep both articles since they are not duplicates per se. There are some people who would say that you would also exclude the abstracts here since like it's basically the same article. But what I prefer is that I resolve only the duplicates at this stage. And I know that these two are not duplicates per se, but one of them obviously will be excluded since one is an abstract and other is the full text article. So I would select keep both articles. So you could go on with that. Let's just get into how you would. So before you start screening, it is always important that you resolve every duplicate here, because once you do like when you're resolving your duplicates, the number of articles here also decreases. So that's like relieving your burden. Okay, so now we have the articles. This is a filters option. In Ryan, when you select a form, like for this, I had selected meta-analysis. So they already have a set of keywords that they would consider under inclusion or exclusion. So that's like predefined from their end. Obviously, if you're doing something which doesn't match this, you can remove them. And then I would add some keywords here of my own, for example. Or So I know I'm including all articles which have HRT in them. So I would just put hormone, for example, hormone replacement. So it highlights the study for me. I So let's just look into this study, for example. It's considering hormone replacement therapy and cancer mortality in women. And it does have lung cancer included in them. I could perhaps look into whether they considered non-smoking women, if they considered women who do not have any genetic predisposition to cancer, but I am not getting any information on that from the abstract. So what I'd do is I'd include this because it's like majorly matching to my criteria. And then later in the full text screening, I can look into the study's PDF and see whether what kind of outcomes they've reported. And it's a cohort study as well, matching my inclusion that I want to include all observational studies. And then I proceed to the next. Um, so this way you can cycle through all articles here. This, for example, suppose I'm excluding a case report, and this is a case report. So I'll directly select exclude. And suppose I'm not going through the study, but suppose this is an article that I have some doubt in. I would like to get someone else's opinion on this. Then I would select maybe here. Filters make your life really easy. So this review term is usually used only in reviews, and I know I'm excluding them. So I just select, I know I'm excluding case reports as well. So I'd select both of these. Yeah. So I'd select both of these, and I'm getting all the articles which have those two keywords. So it is necessary that you not blindly exclude them. Just look into it briefly. I see this is a case report, I exclude it. This is a case report as well, I exclude it. Similarly, you could go through all articles like this. And okay, so I'm just including some of them for the sake of demonstration. It's wrong, but just showing how to export these articles. Suppose I have 6 articles here included, and now I want to export these. So what I do is here, there's an option of export. The filtered, I'd select filtered because 5 articles have been included here. Here, it's better you would get in CSV format because title abstract full text screening, you want to get the URL properly in a sheet from where you could use the URL, look into the web, download the article, and then see whether it matches your study or not. So I preferentially use CSV format. Then it's your wish whether you want to include these as well. For example, in the labels, what labels here means is that you could add a note here, for example, miRNA, miRNA, for example. I'm just including it. So that's a note I've mentioned, and I want to see that note in my CSV file as well. So when I export, I'd use filtered CSV, and I'll keep the labels as well, and export. So when you select this, you get the email into, you get an email to the registered email in Ryan, in which you can download the results, and then you can proceed with your full text screening. So I think this much is it for Ryan. Does anyone have any doubts till now? I guess not. So I'll proceed. So Ryan has a full text screening option as well. So if you enable it, then all my the 5 articles that I got here would be transferred to full text screening. Now, ideally, I would suggest not doing full text screening in Ryan since it's still in a beta version. It's better if you do it in Excel sheet, but some people do it in Ryan as well. It's honestly your convenience. All right. Okay, so back to our PPT. So once you're done with Ryan, you've say you've completed your screening. Now you want to move into extraction. So extraction is, so this flowchart again shows what you do from the beginning. Your review question, you would search for studies that is screening, selecting the studies properly, title abstract and full text screening. And then comes data extraction. And data extraction is one of the most important steps, and one of the steps in which people take it too lightly or they make mistakes here. And the consequences of extracting data incorrectly is a potential editorial comment later. Suppose your article is gone through all, like, first of all, if your data is incorrect, then if you're submitting to a good journal, their reviewers will see that you've extracted a data incorrectly, and that would lead to your rejection, the rejection of the paper. And even if that somehow your paper goes through peer review and it is published, then if it is noted by any other researcher, they put a comment to the editor saying that your data has been extracted incorrectly, that would lead to retraction of your paper. And that's like one of the biggest form of like errors one can make, and it has devastating consequences. So extraction needs to be done properly. It has to be reviewed by two people at least. Once it is like one person does the extraction, for example, and a second person, the leader perhaps, or anyone assigned, needs to review each and every number that has been extracted correctly. And these numbers hold great consequences to getting your meta-analysis, if you're doing analysis further, getting that done correctly. So how would you do your extraction? Extraction is again the same Pico format. So what ideally one would do is, once you get your full text articles, you want to first create a pilot data extraction sheet. A pilot data extraction sheet will help you identify what are the common outcomes across different papers. So what, like, you would create an Excel sheet. I'm sorry, you would create an Excel sheet in which you would ask the people who are extracting the data to include the study title, the name of the study, the duration of the study's inclusion criteria, the study's exclusion criteria, their intervention arm. Suppose it's a drug, then the name of the drug, the dose of the drug, whether any additional medications were given. Similarly, for the control arm, if it's a drug, then you would include all these subheadings. And finally, you would include a last column, outcomes. So the people who will be extracting the data, they will detail all the outcomes which are present in the study. Then you can go through those outcomes and see if there is any overlap. Suppose pain score has been reported in visual analog scale across 5 studies. Like, if it's reported across 3 studies in minimum, then you can take that as an outcome, no issues. So you look through the reported outcomes, and for example, pain score reported in visual analog scale, you see that in 5 studies. Then you would create a column which would help the people who are extract that specific data into those columns. What would happen next is that if it's a systematic review, you just like summarize the results and you write it in your results section. If it's a meta-analysis, then that will be going further towards using any analysis software like R, Revmin, Open Meta-Analyst, which can help you pool these studies together and help you actually understand whether the intervention was better than control arm in any form of outcomes. So yeah, Dr. Deepika, yes.
Ma'am, could you please name the software slowly?
Okay, I'm sorry. The softwares for conducting a meta-analysis, I just put it in the chat box as well. It's R, Revmin, Open Meta-Analyst, and yeah. So Revmin is very simple to use. So is Open Meta-Analyst. R is quite difficult, but it's the best because you can perform any form of meta-analysis. There's Bayesian meta-analysis, there's network meta-analysis, which is not really possible in Revmin. So for that, you would need to use R. We will not be covering data analysis in our workshop since it's out of scope, but you could look into this further. So like I mentioned here, this again is the pilot. These headings are what you want to include in your pilot extraction sheet and your summary sheet for instance, the author, the journal, the research question, the conceptual framework, hypothesis, and methods would mean basically the inclusion and exclusion criteria, the study. If it's, say it's on gestational diabetes mellitus, you want to see how the authors defined gestational diabetes mellitus in their population. What was the criteria they used? What was the cutoff they used? So accordingly, you can write that in your sheet. And if there is any deviation from the guidelines, then you could mention that in your results section. So again, when you're like doing your when you're extracting data, you want to primarily make three sheets. One is your summary sheet, one is your baseline sheet, and one is your outcome sheet. So summary, again, as I detailed before, that will be your the study design, for example, the inclusion exclusion criteria, the information on the drugs given, the intervention, the control, what the results were. In the results, you don't have to mention like each and every result. It maybe you could detail just the outcomes reported and the conclusion. Say drug A was get better than drug B in controlling GDM, for example. Then your baseline parameters. In the baseline sheet, age, gender, BMI, for instance, or parity, or the drugs they are taking while they were being enrolled. So these are some parameters which are included in baseline. You would ask what implications they have. For a systematic review, you can pool the data and report a population of X years, of a pooled age of, say, 56 years, and ranging from 45 years to 64 years were included in our study, for example. So mean age will help you pool your results. That's one. Second would be, again, to like qualitatively analyze your data, say maybe more, I'm sorry, like if it's on children, for example, then more male children were recruited across all studies. So that itself is a bias which you could discuss in your discussion section as well. And a third reason why you are extracting baseline parameters is to help form subgroups in your meta-analysis. So okay, so for example, there is a drug which is analyzing, and you're trying to analyze if its effects in diabetes, and you have two sets of population. One, like you have the entire population, then you have then there's obviously the male population and the female population. If if the study in consideration is reporting this data differently, like in male separately and female separately, then you could create a subgroup of men and women. So only in men, only in women, and an overall effect across all population, what was the effect of the drug. So that is again in the meta-analysis, and we don't want to go much into details of that. Then the outcome sheet is obviously the outcomes, whichever is common across all these studies. And one thing here, which many researchers struggle, is the conversion of data types. Boris, can you launch the third poll, please? So here, I'm asking whether you can pool different data types to like different methods of reporting data together. Like, can you compare a mean age of a study with the same age, but it's reported as a median in a different study? Okay, so the answer is basically no, you cannot do that. Because these are fundamentally different forms of, like, they have different meanings. If you've attended the biostats class, which was held in the workshop series, then you know that mean means different from median, means different from mode. Those all, they are different measures of central tendencies. And it is a norm that you can only compare like like form of reporting. Like if mean age in a study was uh, 10 years, for example, and mean age of in a separate study was 20 years, then you can compare that. Say that study B has included uh, a population with a higher age of mean age 20 years. But if it's a median, then you cannot scientifically state that, even if you know it in the back of your mind that no, 20 median is definitely greater than 10 mean, but you cannot state that. You have to compare the value of median and interquartile range into mean and standard deviation before comparing two results. So why I'm stating this is because when you're extracting your data, what people do is they extract the data as is. So if you've been asked to extract your data in mean SD, then people, if in a study it is reported as median IQR, they extract that data, and that data means nothing because you cannot pool it, like you cannot aggregate it together with the other reported data. Everything needs to be converted to a same measure before doing anything, before interpreting it, or if you want to do an analysis. And for basically for meta-analysis, mean and standard deviation is the effect measure that is used for analysis. There's mean standard deviation. There is the n and total, like event in total. It's especially used for adverse events. So number of adverse events, say tachycardia, then 5 cases out of 100 cases. So that will be n total, and you could pool them together. So I just want to quickly show this website to you on converting data types. Okay, so then if you search the net, you will find a lot of websites that help you convert your data types. This is the one I use, and it's like preferable you use this because you get the study from which they've derived the said conversion. Like there are published studies which help you understand the whole mathematics behind why you are using a said formula for converting a data type to another. So you can cite them in your methodology section. So I'd just like to highlight this scenario too, because this is the one which is most commonly used. You always have your data in, like most of the studies, they report their data in IQR and median. And you want to convert this to mean SD. Say a sample size of 11, you have 5, 10, 20. Then you just run this. It helps you, it gives you your mean and standard deviation. And say you're calculating it to only 2 decimal places, then this will be 11.84 plus minus your standard deviation of 12.72. So there are different there are other ways as well. Like suppose you have the range, the minimum and maximum, and the median, then you can convert that into mean and SD as well. And this is another one. If you have like every data which is stated over, you have the range as well, the minimum, the quartile Q1, median, the Q3, and the maximum of the sample, then all of these could be used to get your data. Then there's the option of detect the skewness. What skewness tells you, like there's a reason why people report it as median IQR instead of mean SD. And that reason is that their data is heavily skewed. That is, a population, suppose we're considering mean age, and I'm including people from less than 30 years, for example, in my study. And I have more number of my population closer to the 20 than the 5. If you can see the number here, for example, if it's 5, 10, and 20, the median here would be somewhere, I'll just suppose the median of this sample is 17. So I know that the data here would be more skewed towards the third quartile. I have a lot of my patients in my study which are skewed towards one side. So detect skewness, it would show me. Then I can analyze it here. So that will help me understand whether my data is skewed or not. Now, what are the implications of this is that you can convert your data into mean SD, but you take it with a pinch of salt. If your data is skewed, then it's not probably accurate, but this is the best you have, because the conversions given here are majorly for near normal distribution. But um, like if you have to do a meta-analysis, then even if a study is skewed, you'll have to convert it to mean standard deviation, and you could perhaps mention that as a limitation of your study in your discussion section. Or an alternative method would be directly like emailing the authors, saying that I'm conducting a meta-analysis, and I would like if you could give us your raw data or your mean SD. And if they reply, that's well and good. You can get directly data from the authors. Okay, so I just have a couple of things I'd like to discuss, like 2 more slides. There's this quality assessment. We won't be going into the detail of quality assessment, but quality assessment is essential for systematic reviews, and meta-analysis. What quality assessment helps you to understand is that whether the study has properly followed an appropriate methodology in accordance to their study design, and whether all outcomes have been reported, and whether there is any form of subtle bias which the study has introduced. For instance, if you're including any trial, and the trial is the randomized control trial is an open label study. What open label means is that both the patients and the ones who are giving the intervention, the doctors, both of them know which patient is supposed to get what drug. So that kind of defeats the purpose of blinding and introduces a bias there. So that decreases the quality of that study. So there are different parameters based on which quality assessment can be done, and there are different tools for conducting quality assessment. And each of those tools have a separate rule of doing it, and you can find that in their website. So I'm just stating the tools in the chat. You can look into them later. So ROB2, Robbins, and NOS, these are like one of the most common forms used. NOS is for observational studies. Robbins 1 is for non-randomized studies. That is again basically all observational studies and non-randomized trials. And ROB2 is only for randomized studies. So this again are the all forms of tools here. The ones which are mostly used are again ROB2, NOS, and Robbins 1 as well. So again, quality assessment, it assesses different kinds of studies, whether they follow their hypothesis, whether the methods were correctly done, if they adhered to their protocol or not, if there was any deviation from the protocol, why was there a deviation, whether there was a drop in patient population, and if it if you're recruiting, if you've randomized 100 patients and 50 patients drop, then that's definitely a big bias there. Now, you don't have to think whether 50 is big or not from your end. There are guidelines. For example, in ROB2, it says 5% of the patient drop out. If more than that, then it's a bias. That again, you can refer to the ROB2 website, which has a nice Excel sheet and a PDF, which helps you understand different domains and what the weight of each domain would be. So thank you so much. I know this has been a very long session, but thank you so much for sticking around. If you have any doubts, you can ask. And the post-event questionnaire has also been posted in the chat box. So please make sure to fill that out. If you have any doubts, please, you can unmute yourselves. If not, I'll just address the open API question and we can close the session for today.
Hi.
Hi.
I had some very basic questions.
Mhm.
It might be a little bit dumb, but where exactly are we leading up with this? Like, is our entire objective to perform a systemic review or meta-analysis, or are we using that as the broad strokes to frame our own study?
Okay, so conducting a screening and data extraction at this level, like doing this intricately, that is doing a whole proper following a method for extracting data, doing it like as accurate as possible, is necessarily like done only for doing a meta-analysis or a systematic review, or a review per se. I'm doing a review and I want to publish this much is only. And there are people who do meta-analysis and then they find some kind of gap. For example, I'm doing a meta between two things, and I find at the end, despite everything, there is no like there's high disagreement between the studies. I'm not getting a proper the intervention is better or the control is better. Then after this, I can publish my own protocol saying that this were my findings from my study, from my meta-analysis, and I understood that from the current evidence there is no clear consensus on whether this drug is better for said condition. Hence, I want to conduct an observation study, a cohort study, or something, or a trial, which will help me understand this like generate evidence on this topic. So, but basically, essentially, screening and extraction is done only for reviews.
Okay.
Yeah.
And another question I had was, in a real life scenario, who do these reviewers turn out to be? Are they professors? Are they colleagues? Are they unknown people within the community?
Okay. Like you're asking in the study, like the team members of a systematic review?
Yeah, like at multiple points, you said two people review this. It goes to
Yeah.
at least two
Okay.
reviewers. Yeah.
Yeah. So, okay, so meta-analysis can be conducted by anyone, really. If it can be a bunch of professors together, they're interested in GDM, for example, and they want to compare a certain intervention and control, and they're doing it together. Or it can be international collabs as well, because this is like the only study where you do not need to have a study setting, a study like duration, recruitment of participants. This is like the much easier form, yet much what do you call valuable, you would say, because it ranks the highest in the level of evidence and yeah, in the pyramid. So it can be anyone, it can be a bunch of colleagues, it can be international collaboration as well, it can be students as well, if they have a good statistician in their team.
Okay, but mostly they are all people who are co-authors of the
Yes, co-authors,
meta-analysis.
right.
Okay. All right, great. And could you just repeat what Remmen and Open meta-analysts do?
Okay, so this is only for the meta-analysis, like the analysis, data analysis stage. This again is specific to doing a meta-analysis only, in which you have an intervention arm and control arm. Just say drug A and drug B, and I'm reporting the pain scores. I found like suppose my intervention has 10 patients and my control has 10 patients. In the intervention, I found a mean VAS score of 5 plus minus 2, for example, and in the control I found 4 plus minus 1. And then I report for different studies, like study number A, X et al, Y et al, Z et al. For all these studies, I extract this said data. After that, I put this data into RevMin or R or Open Meta-Analyst, and that helps me like pool all these results together to understand whether the VAS score was actually better in the intervention arm or was it better in the control arm.
Okay.
Yeah.
All right. Thank you.
You're welcome. Does anyone else have any questions? Okay, I guess not. So Open API. Open API I shared, I think, in my last to last session, which will help you calculate the sample size for your observational, like for your study. I'll just quickly share the site. So this is Open API. What this helps you, like there are a lot of functions here that you can do. But majorly what it is mostly known for is sample size calculation. So for example, I want to conduct a cohort study. Okay, I'm not sure why it's not opening, but basically, for calculation of sample size, um, you can input your data like the known published prevalence of the study, the power of the study that you want, and if you have a limited sample size, say you have only 200 participants, then that would be going into the population size, and then it will help you calculate what is the minimum required number of patients or population you have to include in your observation in your primary study in order to get that kind of power, or to like actually get a discernible difference between two groups. So that's what OpenAPI does. I think it's lagging from my end, but you can look into it. That's like basically what OpenAPI does. It's mainly for sample size calculation. If you would see there, it also has like it can help you do analysis as well, like ANOVA and t-test. But then it's better, like more conveniently done in SPSS and Stata. All right. So I hope that answered your question. Does anyone else have any other questions?
Hi, one more.
Yes.
The Prisma flowchart that you showed, is it to be included in the meta-analysis the way the checklist is supposed to be, or was that just for our guidance?
I'm sorry, the flowchart?
Yeah, the flowchart you showed, is that just for our understanding, or
No,
is that to be shown why we
that is to
excluded
be
certain
shown. That
things?
is to
Okay,
be shown. You'll have to include it as a figure in your, like preferably as a figure, or you can also include it as a supply file if you have a lot of results, but it has to be there.
okay, thank you.
You're welcome. So I think we can wrap up today's session. Thank you so much, and I'm really sorry for extending the session. If you all can turn on your cameras, that would be really great. Okay, then, all right. Thank you so much for joining today, and I hope you understood something from this session. And feel free to drop any questions if you have into the group, or mail us at our email ID. And next session, I would just like to say that it's really important because it discusses on manuscript writing, and everything that has been done till now was the background work. But the next session is the one which will actually be reviewed by many people, and that will like decide the fate of your study. So please do join in, and I look forward to seeing you in the next session. Thank you so much, guys, for joining. Bye bye.
Bye bye.